today we will learn about the map interface in Java. Okay, so the map data structure is used for storing key value based pair. So whenever you have to store any data in the form of a key and a value, then you should choose the map collection. So the commonly used implementations of map interface are HashMap, LinkedHashMap and the third one is TreeMap. So the HashMap is the most commonly used implementation of the map interface or the map collection type. So basically all of these are key value paired, but this is unordered. It doesn't maintain any order. Okay. But the good thing about this is whenever you try to put anything into the map or get anything in the map, the performance of these two methods is very good. It is, constant time. What do you mean by constant time? You mean that as the size of the map grows and grows, these operations will not become slower and slower as you continue to add more and more data into the map. It will remain the same. Performance will remain the same. It's a constant time performance these methods are giving. Whereas, LinkedHashMap has all the features that are present here, but it has an additional method. It maintains insertion order. Okay. So the order in which you have inserted values in your map, that is maintained in case of a linked hash. And a tree map is, sorted. So it will sort based on key. Okay. So that is why, these are the different commonly used type of map. But the most popular is the hash map. So now we will try to understand the internal working of a hash map. It is a very important concept. And if you understand this concept, you will realize how much deeply things are implemented in Java. It will really give you a feel of learning Java today if you understand this topic nicely. Okay. So let's start. So internally, a hash map is built using an array. This is called the bucket. Okay. This is an array. And now each of the index of the bucket points to a linked list. Similarly, each of them point to a linked list. And what does the linked list store? The linked list stores both and value. This is stored here. This is the pointer you have as we have already learned in linked list. The second part of the element of the linked list contains a pointer to the next element. So this is pointing to the next one. So it is storing your key value pairs. Now there is a special name or special class for representing this key value pair. It is called entry. You don't need to go deep into what is entry, where is entry. You can only understand it as a key value pair. Okay. So all of them will point to linked lists and they will contain, each of the node of the linked list will contain the key value pair. So when you try to add something in your hash map, for example, you are doing roll number 1 is Sumit, roll number 2 is SPS, roll number 3 is Ravi. Okay. So this is the key and this is the value. And you can pass any object in the key. Here we are passing 1 to numbers. So these are not int small int primitive. These are integer, which is also a class in Java. So when we say a class in Java, it has a equals and a hashcode method in that. So it has equals and it has hash. We already studied equals and hashcode previously. So if you didn't understand it or you have any doubts, please revise the topic. It was very important in learning this. Okay. So what happens when you call something like put 1, okay? You call it on your map object. Map. So you're doing map is equal to new. So you can write here hash map also, but we are representing it with the interface. So what will happen is when you call 1, it will calculate the hash code of this. For example, the hash code of this can be 1 also, or it can be any number. Supposedly that if the hash code is 1. So in this case, what will happen is it will go, because the hash code is 1, it will go to the first index of the bucket. Okay. So in the bucket at first index also we will have a linked list. Like every index points to a linked list. So it will go and add this 1 Sumit in the first element. Now when you do map.1, what it will do, again, it will calculate the hash code of the key. Hash code is 1. So it will go again to this bucket. And then the next step in this process is, when doing a get operation, first it will reach the index. Then it will traverse each the element in this linked list. And for matching an event, what it will do, it will call the equals on the key. So what it will do is 1 dot equals 1. For whichever entry it will find it to be true, that value you will return. So you will say one roll number cannot be assigned to 2 students. Yes, your point is correct. But suppose if I had, instead of creating this map with integer, if I would have created a more complicated use case. So this was a pretty simple use case, but we will, let's, with the help of code example, create a more complicated use case where this value will not be integer. It will be a class in itself. It will also be a class, and the value will also be a class. And then in that case, what can happen is that we can have more than one entries here. So let's see that code example first, and then it will be more clear for you. Hello. So in order to understand more deeply, let's take an example. Here we have a car class. Okay, it has 2 properties. First property is model, and the second property is its year of manufacturing. So we have created a constructor for this car object, and we have overridden the equals and hashCode method of the car object. So 2 car objects are considered equal when the year is same and the model is same. Both need to be shared. Here we have used object.equals, but you can also do like this dot equals. Okay, so you can do this also. The object.equals places an additional null check, which is for coding safety, but yeah, you can impact. And in the hashCode method, again, we will use both these values to create a comprehensive hashCode. Now what does this hash method do? It, you see the description says generates a hash code for a sequence of input values. So whatever sequence of input value you give to this hashCode method, it will use all of them to create a unique integer for unique or nearly unique integer for this. We have overridden toString also, but this is only for visualization purposes. So now what I'm doing is that we can see that the name of this Java class is HashMap custom object. So the name of the public class in this file should match with the name of the file here. You can create other classes in this file as well, like we have created a car class, but they should not be public. Only the name which matches with the file name, that class should be public. So generally we create one class in one Java file, but public can only be one. Okay, so this is our example where we will test. So what I am doing here is, at line number 35, I am creating a hash map. Its key is car type and its value is a string. Okay, so then I am calling the put method of the hash map. You can see the put method takes key and value both. It is used to save anything in the hash map. So I am creating 3 car objects here. Okay, and I am saving them. So as you can see, the car constructor takes 2 values. It takes the model description and the year. So I am creating 3 objects. So first is Honda 2020, then it is Toyota 2019, and then there is Honda City again 2020. Okay, and in the value I have added some custom strings. So for one I have added sedan, the second I have added SUV, and then I have added. So in this case, when we will call put for this key, it will go to the hashCode method, and it will create a unique key for combination of year and model. And based on this unique key, it will go to that particular bucket, and it will save the value in the linked list, which was adjacent to. So here the case is that all the hashCode of all these 3 key is different. So when I will run this code, you can see when I execute line number 38, it is calling the hashCode method. If you try and evaluate and see what is it returning, it is returning some particular integer. If you want, we can note the integer as well. Let's copy its value and just mention it here. Okay, so it has given us the hash code. So after execution of line number 38, we can see that map size of the map is 1. So it contains 1 value. Now after execution of line number 39, again it will calculate the hash code. Let's copy this hash code as well. Again, now in this case, it has created a negative integer. It is free to create because negative numbers are also integers. Okay. So after execution of line number 39, now we can see that the size of the map is 2. And now after execution of line number 40, if we will see, again it will calculate the hash code for the key. Then it will go to that bucket and then it will store the key and value both in the linked list. It is called calculated this third integer value. But if we see after execution of line number 40, now the size of the map is 3. It contains 3 keys and 3 values. Okay, so now I want to demonstrate a very tricky thing to you. The tricky thing is that if I remove the model from the hash code calculation, which means that the hash code is only dependent on the year. In that case, what will happen? This car object and this car object both will contain the same key. Okay, so what will happen in this case? But you will see that the map will still contain 3 elements. But internally, what will happen is in one bucket in the linked list, there will be 2 elements. And in the second bucket in the linked list, there will be 1 element. So if, as you can see here right now, the map contains 3 elements. But if I do something like this, I remove the model from the hash code, only from the hash code calculator. In equals, I'm not doing that. Okay. This is done for introducing a hash collision, which means a hash collision means when 2 keys have the same hash. Okay. But they are not equal. If they are equal, then the first will override the second value. But if they are not equal and they have the same hash code, they will be placed in the same linked list for that particular bucket. Their bucket will be same. So if I run this code again, let's check what the hash code is published. So the first hash code is 2051. Let's copy these values again. So the first value is 205. Okay. You can see here that the map contains 1 value. Okay. Then the second value that we will get is 2050. Okay, good, fine. Now for the third one, now you can see that right now here, the map contains 2 elements. Now for the third one, again, the hash code is same, 2051 again. So earlier we were having 3 different hash codes, but now we are having only 2 hash codes. So 1 hash code is common. But still you will see that the map will contain 3 elements. Earlier, so it is like if you try to visualize in code, earlier is, let me explain it to you. Earlier, what was there was, earlier for these values, for this hash code, so assume this is the bucket. So here you were having this one, Honda 2020 as key and sedan as value. For this one, you are having Toyota 2019 as key and SUV as well. And for this one, you are having the City 2020 as key and compact as value. But in this case, now things will be a bit different because we have introduced a hash collision. What will be there is in the bucket, we will only have 2 entries, and here we will have 2 values in the linked list. So first will be Honda 2020 sedan, and the second will be Honda City 2020, and this will remain as it is. So this is the new structure and this is the old structure, and we have introduced this difference by changing this hash code. We have removed the model from this hash. So for this particular bucket, 2051 bucket, we have 2 entries. Entry 1 is this and entry 2 is this. And for this 2050 bucket, we have 1 entry. So when we will call get on this, it will traverse entry by entry. and it will do a equals on this Honda 2020. If you have passed Honda 2020, and then it will return you sedan. If you have passed Honda City 2020, then it will return you compact. Let's see that also. Here I'm doing, let me do that. Okay, so I'll have to rerun this code. So what I will do here is, I will say map dot get, okay, and I will pass it this one, this object. Okay, let's print it as well. I'm writing system.out.println to print it. Okay, so let's rerun this code. I'm removing these debug points. We have understood the role of hashcode. Now let's try to understand the role of equals. Okay, so now we have reached this point, line number 43, where our map already contains 3 values. There is a hash collision, and we are trying to get the value, which is this one, Honda City. So when we do this map.get, you see, if I execute this, it will call the equals method. On which object it is calling? If we inspect this object, this is the car object, which is, here the key of your map. So it is calling the equals on the car object. And then here you can see that right now, first it is trying to check for this object, the 2020. You see here, if we see this, we have passed this Honda City 2020. So that those values, Honda City 2020, are assigned to this model and this year, because it is matching with this instant. And now HashMap will pass 2 arguments to this equals method. First, it is passing Honda 2020, as you can see here. So it will compare the year and it will compare the model. And if you see the result of this, you will get false. Because you get false, now it will again call this method with the other value, second value. What is the second value in the map? This one. Okay. So you can see here, if I inspect this O object here it is Honda 2020, which HashMap has called this equals method. Okay. Now, again, it has called this time. Again, it is Honda 2020. It will call once more. Now, what does it get? If we see the O object, HashMap has called again this equals method, and again, this time it is called with Honda City 2020. And our original model will always have Honda City and year will always be 2020, because this is our object that we have passed as a key. Okay. So on this, it is calling equals many times. The HashMap is calling until it finds a match. So now in this case, it will get the output will be true, and because the output is true, you will get this compact as your output. If we see on the screen or in the console, compact is printed. You can see it here, compact is printed. Why it is printed? Because it has found the equals to be true for this key, Honda City 2020. So this is, how equals and hashcode are very important, and you have to be very careful while defining an equals and hashcode for keys of your hash. Everything will depend on them. So for the purpose of clarity, let's try to visualize once more. So if earlier it was not clear to you, now it will be clear. Okay. So when we added this first object, the hashcode was 205. So assuming that this 2051 comes here, somewhere here. Okay. 2051. Okay. So it will add, first time it will add this Honda 2020 into this. Okay. Then what you are adding? You are adding Toyota. Okay. So the hashcode for Toyota is 2050. So this is the 2050 bucket. So here it will add Toyota 2019. And here these will be empty, right? Now the third time when you add this Honda City 2020, it will come here. Honda City 2020, like this. Now we have 3 elements in the HashMap. Now if you do map get and you pass key, new key, and you pass Honda City 2020. You created a key and you do map.add. So what it will do? First, it will calculate the hashcode of the key using this. In our case, we are only using the model, so it will not use this. It will only use 2020, and it will calculate the hash. So the hashcode will be 2051. So now it will go to this bucket. After going to this bucket, it will see that the linked list has 2 elements. So it will go to this first one. Now what it will do, it will call equals on this key. Okay. Here I have only mentioned the key, but we also have the values here. For every key, we have a value as well. For Toyota, the value is SUV. For Honda 2020, the value is sedan. And for Honda City 2020, the value is compact. Okay. So what I was saying was, now it has come to this linked list, and it sees that the linked list contains 2 elements. So now it will run equals on the key one by one. So what is our key? Our key is this new key 2020. So in this case, now our key is this. So what it will do is, it will use this key new Honda City 2020 dot equals. Okay. And it will use the first key, which is new key Honda and 2020. Okay. So as we have seen in the code earlier, that we were using both the values to compare equality. So this will return false. So because it returned false, now it will jump to the next element. Okay. Now it will again do the same step, but in this case, it will do it on new key and city 2020. Okay. So in this case, it will find the response to be, and because it finds the response to be true, so your method will return this value. The get will return compact. Okay. This is the point. Now I want to show you one last. The last point is, here our hash code was using year only, but our equals was using year and model both. What if I change my equals, and equals also uses only the year? Okay. Now what will happen? Let's see. Okay. So hash code for these 2 keys will be same, but equals for these 2 keys will also be same. Earlier equals was false, but now equals is also same. So let's see what happens. So after execution of first line, we can see HashMap contains 1 value. After execution of second line, we can see HashMap contains 2 values. But after the execution right now, what if we see in the map, we can see Toyota 2019 SUV and Honda 2020 sedan. But after execution of this line, something different will happen. What will happen is, after line number 39 is executed, the map still contains 2 values. And this first value, the first value is present, Honda 2020. Toyota is also present, but when we try to add this value Honda City 2020, this is not getting added. Why? Because it already contains 1 value for this. So after execution of line number 39, you can see that the value has changed here from sedan to compact. Why it has changed? Because the HashMap is treating these 2 keys as same. Equals is also true and hashcode is also true. So it has overridden this sedan value with this compact value. And after execution of these 3 lines, we only have 2 objects in our HashMap. And the first value sedan, which was for Honda 2020 sedan, that has been removed. Absolutely. So always remember, when creating keys for HashMap, equals and hashcode should be precisely correct, because these will be used to put elements in your map, get them back from the map, and if you don't override them, implement them correctly, you can lose some data as well. So one can override the other as well. So in the next video, we will learn about set interface. Keep watching, and if you feel any doubt, go back and revise the equals and hashcode section and then come back to the section. Then it will be more clear for you.